Okay, today we are going to be looking at placing both fractions and decimals on a number line. We're going to start with an example. On the number line below, plot the point 0 and 4/10 and 0 and 75 hundredths. So I know from what we've learned before that I need to divide this into 10 pieces. I'm going to put a middle line for my my 5/10, and then I can divide this into 5. 1, 2, 3, 4, 5, and divide this into 5, 2, 3, 4, 5. So there are my 5 pieces, and now I can label them. And I know that this is 1/10, this is 2/10, 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, and 9/10. Now, 0 and 4/10 is really easy because I already labeled that with my tenths. I'm going to do this one. This will make a circle, and this one I'll make a triangle, so I can mark them distinctly on my line. So 0 and 4/10 goes right here. Now, 75 hundredths requires one more step. I need to decide which tenths this is in between. Now, because there's a 7 here, I know it's going to start at 7/10, and the next number up would be 8/10. So it's going to be in between here. So I need to divide these into 10 pieces. So I put my midline, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Now 75 is actually going to be right here, right in the middle. So 0 and 75 tenths goes right there. Now here it says rational numbers are all positive and negative. And you know what? I don't actually know what Mr. Johnston wants to put in those blanks, so I'm going to have to skip that. But this is terminating and repeating, I believe, decimal places, but again, I didn't remember to check with him, so I'm going to leave that blank for now. What we will look at are some examples of rational numbers. So the difference here is that these are fractions or decimals, and they have either a terminating decimal or a repeating decimal, a repeating number. This is going to be 2 and 2 and 2 and 2 and 2 forever. That's considered a rational number. These are rational. These are not. So 3 and 1, 4, 5, 1, 9, this is actually, I believe, the number for pi. But this does not have a repeating number, and so it's not considered rational. This is just a different series of numbers that change as it goes on. This is always the same. Numbers that do this would be like a third. A third has a repeating 3. We can never divide 100 equally into 3 parts, and so it's continually repeating 3. Now on the number line below, plot the points 1/4, 3/4, 1/2, and it says negative 25 hundredths. There's tens and hundredths. So this is going to require a little bit more work than what we were used to, because not only do I need to identify where these fractions go, I also need to identify where this decimal goes. Now, I'm looking at this, and I know the easiest thing to do first is going to be to place the half, because if I divide this whole into half, then this right here is my 1/2 mark. I have 2 pieces, and this is 1 piece that I have so far. Now, just to be consistent, I can also mark it down here. This would be negative 1/2, but that's not something we're required to label this time. The next thing I see is that I have 2 sets of quarters. So I can divide this now into 1, 2, 3, 4 pieces, which is what my denominator represents. And to be consistent, I'll do the same down here. So 1/4 belongs here, and 3/4, 1, 2, 1/2 is the same as 2/4, 3. So we have 3/4 here. So I'm going to put circles around the ones that I was told to mark. I've included a few pieces of extra information, but these 3 are the ones that we were instructed instructed to mark. And then we have a negative decimal place. Now this isn't too tricky. The only difference is that instead of going towards 1, we're going to go the opposite direction starting at 0. And I happen to know that 25 hundredths is equal to 1/4 or 1/4. Because it is negative, that just means that it's going to be in the opposite direction. So negative 25 hundredths is equal to negative 1/4. This is just the opposite. And so my 0 and 25 hundredths is negative 25 hundredths. Now if it helps you, you could always put decimals on one side and fractions on the other. There are some that are very common and you will learn them. For example, 1/4 is 25 hundredths. And 1/3 is 33 3 reoccurring. Let's look at our next example. This will be our final example, and then you'll be able to work on some practice problems on your own. Here it says, which numbers represent the points on the number line below? Circle all that apply. So this is just like the example we saw in our Think About It earlier in another video. What I can see right away is that my number line includes 2 whole numbers. So we have 1 and 2. Now I know that my dot is on this side of the 1, so my value here is going to be in between 1 and 2. So I can go in and eliminate right away some of those that are smaller. This right here, 2/6, is definitely smaller because it doesn't even have a whole completed. It's just 2 parts of a whole. 8/5, that might work. Let's see what my numbers are, or what my whole numbers are divided into. We have 1, 2, 3, 4, 5, 6. We have 6 pieces. So this is 1 and 1/6, 1 and 2/6, 1 and 3/6, 1 and 4/6. I switched sides because it was getting too crowded to do them all on 1. 1 and 5/6, and then this would be 1 and 6/6, which is 2. So I know my fifths is not going to represent that point. 8/6, let's see, that might work, but let's check first. So this is going to be 1/6, 2/6, 3/6, 4/6, 5/6, and then this is 6/6. So then what I can actually do is I can continue to count, because this is 6 pieces, 6/6. This is now 7/6. I'm just counting from 0. We got to 6, and we keep on going. That's 7/6 and 8/6. This is the mixed number form. This is the improper fraction form. So C is one of my options that is accurate. And now I notice here that 8/6 is on the opposite side of 1 and 2/6, which I see here. This is also an accurate choice. Now, again, we know that 2/5 isn't an accurate choice because my whole numbers are not divided into 6 pieces. And finally, I see 1 and 1/3. Now, we might be quick to say, nope, that doesn't work because this is divided into 6 pieces. But I know that some fractions are equivalent. Just like we said earlier that 2/4 equals 1/2, 1/3 happens to equal 2/6, and I'll show you why. We have this whole number here. I'm going to draw some lines out to extend these so we can see it a little bit clearly what I'm going to show you. Now we have 1, 2, 3, 4, 5, 6 pieces. But if we look at it this way, we can make 1, 2, 3 pieces. So this is not going to be a 1/6 anymore. This would be thirds. We can easily convert thirds into 6ths. So if I have 2/6, we can label this again. That's a 6th. That's a 6th. Then this becomes 1/3. So if we have 4/6, that equals 2/3. And then when we have 6/6, that equals 3/3, which is a whole. So indeed, this choice right here is accurate. Now it was helpful because I already knew that 1/3 was equal to 2/6. But now you can see a way that you can check it yourself. If you can equally divide it using another number, using the pieces that you've been given, then you can find an equivalent. So when I put these 2 together and 2 together and 2 together, I made it into 3 pieces instead of 6, which helped me understand why 1 1/3 would also be an accurate answer choice. Now just to show you what you're going to see for your next pages, we have our partner practice. Again, I encourage you to wait on partner practice and do that with a partner tomorrow. We have our final CFU. This is something that you could definitely attempt. And then independent practice, which is another thing that you can absolutely do on your own and be prepared for tomorrow. And we have quite a bit of this today because we have a lot of skills that we're putting into this one lesson. We're putting both fractions and decimals on our number line.